For my thermodynamics project, I have an air fryer. An air fryer is pretty much a high-powered convection oven. It has a heating system that's used to heat air that comes into it, and it has a fan system that is used to transfer that heat throughout the system and heat up the food that's within it. An air fryer is an open system because there can be a transfer of mass and energy in it. There's a transfer of mass by when the air comes in and then is taken out of it, and there's also a transfer of energy when the cool air comes in and is heated in it, and then hot air comes out. The second concept I have is the conservation of energy. An air fryer obviously abides by the first law of thermodynamics. The energy that goes into an air fryer is mostly electrical energy through the outlet or through power. And then the change in energy is mostly internal energy when the food is heated within the system, and the internal energy of that food increases. There also is energy lost when energy comes out of the system, or heat comes out of the system, and when air comes out of the air fryer as well. For my third concept, I have specific heat. The main objective of an air fryer is to heat the air and food within it. Air is what transfers the heat throughout the system, obviously, and the fan moves that air throughout the system to heat up the food. The primary goal of an air fryer is to increase the internal energy of that food. So the specific heat of food is often very close to water, as food is primarily made up of water oftentimes. And you can model the energy absorbed by food and the heat added to the air using the specific heat model. So that's how it applies to specific heat. The air fryer also, my next concept, I have energy balance or energy rate balance. The heating circulation of air in an air fryer can be modeled using the energy rate balance equation. Pretty much the work is from electrical power, obviously from its outlet again. The heat transfer into the system is from the air that's supplied in. And then the transfer of mass through the system is, again, the air in and then the air out. And then the heat transfer out is the heat that's then lost after it comes out. And then for my fifth concept, an air fryer is an irreversible system, heating food in an air fryer is an irreversible process. The air fryer obviously has many irreversibilities when it's cooking food. As it's not an ideal system. Again, heat is lost when it cooks food. As you could see, maybe if you were cooking a chicken in an air fryer, once that chicken is cooked, there is no way to uncook that chicken. The chicken is, cooking that chicken was an irreversible process, and there's no way to uncook it and make it a reversible process.